Welcome back to our channel. If you haven't watched our video on exponent laws, where we break down all the exponent laws and show you how to apply them, please click the link above and watch that first, and then you can return to this video. So in this video, we will be going through some exponent examples where we're simplifying expressions. And these are mostly grade 10 level, but even if you're in grade 11 and 12, you're going to need to know how to do this first before you move on to the more difficult examples. So these examples are taken from past papers. So these are the type of questions you're most likely going to find in your past papers. If you haven't subscribed to our channel yet, please do. We are going to be posting a lot more content that's going to help you prepare for your exams, tests, and just to help you get a good understanding on math and other learning areas as well. So in the first question, we see we have a binomial multiplied by a trinomial. So how we're going to deal with this is we're going to take the first term from our binomial and we're going to multiply it into our trinomial. Okay. And then we're going to take our second term of our binomial, which is minus 2y, and also multiply that into our trinomial. So when we see x times x squared, we're going to get x to the power 3. And then we're going to get x times 2xy, and we're going to get 2x squared y. And then x times 4y squared, we're going to get 4xy squared. And then we're going to do the same thing here. Negative 2y multiplied by x squared, we're going to get a negative 2x squared y. And if you've forgotten or you don't know how to do this correctly, we need to remember that when we multiply a negative by a positive, when we multiply a negative by a positive, we're going to get a negative. If we multiply a positive by a negative, we're also going to get a negative. If we multiply a positive by a positive, we're going to get a positive. And if we multiply a negative by a negative, we are also going to get a positive. So when we multiply the two same signs, we're going to get a positive. And when the two signs are different, when we multiply a negative by a positive or a positive by a negative, we're going to get a negative. So let us carry on. So we get a negative times a positive here. So a negative 2y times a positive 2xy. We're going to get a negative 4xy squared. And then we're going to get, when we multiply negative 2y by positive 4y squared, we're going to get negative 8y cubed. So we begin to group our like terms. So we see that we have a positive 2xy and a negative 2xy. So we could say that we could cancel that, but just so we get a good understanding on this, we're going to group our like terms first. So we're going to say x cubed plus 2x squared y, which you get in from here, and then we from here. And then we say minus 2x squared y, so that's coming from here. Then we see we have another set of like terms, 4xy squared minus 4xy squared. So we say positive 4xy squared minus 4xy squared minus 8y cubed. So positive and negative, the exact same thing, will just cancel out. And so we have that here, and we have that here as well. So we left with x cubed minus 8y cubed. So we're done with this question. If you have any questions, or if you're not understanding something, or if I'm not clear about something, or if you feel like I made a mistake anywhere, please leave a comment down and I will address that. Okay, so let us move on. Okay, let us clear this up first. Okay, let us move on to the next question. Okay, here we see we have the squaring of a binomial. Very simply, what we can do is let's expand this a little bit. And many of us know about the method of FOIL, or we probably heard of FOIL, which basically means first terms, outer terms, inner terms, and last terms. So I don't use FOIL, but if you want to use FOIL, this is what it actually means. So if we get A plus B into C plus D. So our first terms would be this in the first term of each bracket, so A times C. And then our outer terms would be the outer terms, so it'd be A and D plus A, D. And then our inner terms will be these two plus B, C. And then our last term will be B times D, so plus B, D. Okay, so that's if you want to use FOIL. But I choose not to use FOIL. I mean, there's no need for us to remember all that. So a better way to do this would be exactly like what we did for binomial times trinomial. I mean, nothing changes. So 5 minus 4x into 5 minus 4x. So the exact same thing that we did above. So this would work, guys, if you had 2 terms here times 4 terms here, if you had 3 terms here times 4 terms here, this would still work. So what we do is you take the first term here and we multiply it into the binomial, the second binomial, and we take the second term, it's the same thing. So again, this would work no matter how many terms you have here or how many terms here, you just keep repeating this and it will work. So here we'll have 25 minus 20x. Again, we see a positive multiplied by a negative gives us a negative. So we can do the same thing here. Negative 20x. And lastly, positive 16x squared. So what we are doing here is we are multiplying these 4 times 4 and then x times x, we're getting x squared. So we're going to simplify once again our like terms, 25 and minus 20 minus 20 minus 40x plus 16x squared. So we can rewrite this as, we need to rewrite this in descending powers. So we have 16x squared minus 40x plus 25. Okay, so I hope you guys are already getting a better understanding of what we need to do and how we approach these questions. So now let us go on to our next example. Okay, so when we look at number 3, we might think that this looks a little bit more difficult, but in actual fact, it isn't. So what's important to know in this sort of example is that we need to convert the 10, the 4, and the 25 into prime bases. So you could do this with your calculator, or you could use the ladder method. So if you look at 10, the number 10, okay. If you look at the number 10, we're going to write 10, I'm going to draw a line. Then we're going to ask ourselves, which prime number can fit exactly into 10 without giving us any remainders? And we're going to start off with the lowest prime number, being 2. So can 2 go into 10 exactly? Absolutely. Then we say 10 divided by 2, we're left with 5. Then we're going to repeat the process. Can 2 go into 5 exactly? No. Can 3 go into 5 exactly? No. Then we go to the next prime number, which is 5 itself. Can 5 go? Definitely. And then we left at 1. So this is the point that we stop. And then we look at the right-hand side, and we've got a multiplication there. And that's our prime factors of this number. So when we start this example, we're going to say, okay, cool. So we can replace the 10 now with 2 times 5. And we're going to raise that to the power 2x plus 3. We're going to do the same for 4. 2, definitely. 2 again, multiplication. 2 times 2, we know that 2 times 2 can also be written as 2 squared. And that's what we're going to do. So 2 to the power 2 raised to the power 1 minus x. That's going to be over. And then once again, we're going to repeat the process now with 25. 25, 2 can't go into it, 3 can't go into it. So we're going to use 5 once again. Remember, this is not necessary. If you want to do this using your calculator, you're more than welcome to. So 25 divided by 5 is 5. Once again, the lowest prime number that can go into 5 is going to be 5 itself. You're going to get 1. That's going to be 5 squared. So that's going to be 5 to the power 2 raised to the power 2 plus x. Okay, so then we're going to remember that 2 and 5 is 2 to the power 1 and 5 to the power 1. So when we go back to, now we go back to using our exponent laws, and we're going to raise this 2 to the power that's outside and the 5 to the power that's outside as well. How do we do that? We do that by multiplying the exponent of this base by this power and the exponent of this base by the power that's outside. So in this case, it's relatively simple. We're going to have 2 to the power 2x plus 3 because we just multiplied by 1. We're going to have 5 to the power 2x plus 3 as well. And we're going to have here 2 times 1. So 2 to the power 2 times 1 is 2. 2 to the power 2 times negative x, that's negative 2x. And all over, going to do the same for the 5. 5 to the power 4, it's 2 times 2, plus 2x, 2 times x. And now we're going to use our multiplication law. So how we're going to do that is we see we have a common base here, 2 and 2. So we're going to write down 2 to the power 2x plus 3. And then multiplication law states that when we have the same base, we can simply add the exponents. And that's what we're going to do. We're going to say plus 2 minus 2x. Now this comes from here. We're going to do the same with 5. We're going to write the 5 that's in the numerator. The exponent is 2x plus 3. But there's no other 5 on the numerator. So we can't add the exponents, but we do see a 5 on the bottom in the denominator. So what we do here is, now this is division. So when dividing and we have the same basis, we're going to subtract the exponents. Now I would advise you guys to always, when subtracting, put the exponent within brackets, just so that we avoid making any silly errors, especially when we are rushing. So we're going to simplify this. We see we got a positive 2x and negative 2x. So we simplify that, we get 0. So that's what I'm actually canceling out, because when we say 2x minus 2x, we get 0. And we left a 3 plus 2, which is going to give us 5. So 2 to the power 5. And we're going to look at the 5. And so we're going to multiply out this. So this is a negative 1 here. So we're going to say 5 to the power 2x plus 3. We're not going to interfere with that. Negative 1 times 4 minus 4. And negative 1 times positive 2x is going to be negative 2x. And once again, 2x minus 2x is going to give us 0. So we're going to cancel that out. And we're left with 2 to the power 5 times 5 positive 3 times negative 4 to the power negative 1. Okay, and we're not done yet. So you remember one of our other exponent laws where we can change this negative exponent. And so we left with 2 to the power 5, which is 32, times 1 over 5. Because when we move this to the denominator, our exponent is going to change, and that's exactly what happened here. And our final answer is 32 over 5. Once again, guys, if you've got any questions, please leave it down in the comments. Okay, so let us move on to our next question. Okay, clear the screen up. Okay, quite similar to the last question, I would say. So one thing we notice here is that we have no variable, but we have numbers. And we see we have 3 to the power 500, 7 to the power 500, 2 to the power 502. Now, once again, guys, this could look very confusing and you might not know where to start. But what's important is that we apply the basics. So what we do know from the previous example is that the first thing we need to do when we see this sort of question, where we have a large number, if you look at the denominator, we have 42, is reduce everything to prime bases. So when we look at 3, we know 3 is a prime number. There's nothing that can go into 3 exactly besides 3 and 1. We see the same with 7, and we see the same with 2. So we know we can't really touch the numerator as yet. So we're just going to write that as we see it, 3 to the power 500 times 7 to the power 500. And yes, this might look complicated now, but we will see that it's actually very simple, 502. And our denominator, we're going to find 42. Now, 42, we can change the way we write 42. So 42, the lowest prime number that can go into that is 2. We left with 21. Can 2 go into 21 exactly? Absolutely not. So we go to our next prime number, which is 3. Can 3 go into 21? Definitely 7 times. And we know that the only number that can go into 7 is 7 itself. So we know that the prime factors here are 2 times 3 times 7 for 42. So we're gonna rewrite 42 as 2 times 3 times 7 to the power 500. And then we apply our basics once again, guys. So we're going to raise everything in here to the power 500. And we're going to say, okay, 3 to the power 500 times 7 to the power 500 times 2, 502 over 2 to the power 500 times 3. And we're getting this from here, guys. 2 to the power 1 raised to 500, 3 to the power 1 raised to 500, and 7 raised to the power 500. So 3 to the power 500, 7 to the power 500. And we will notice that we have all multiplication here, so we can cancel off 3 to the power 500 and 3 to the power 500. We can cancel off 7 to the power 500, 7 to the power 500, because they're the exact same thing. And then we notice, okay, we have a 2 on the numerator and we have a 2 in the denominator. So we have the same basis and we are dividing, so we're going to use our division law. On the top, we have 502 and we are dividing, so we're going to subtract 500, and that's going to equal 2 to the power 2, which is going to equal to 4. So relatively simple, guys. We might have not known where we were heading initially, but we made sure that we applied the basics, which was breaking this down into its prime basis. And then we began to use our exponent laws, and we eventually arrived to our final answer. Okay, let's clear this. And let's move to our final example. So here we find ourselves looking at something that looks a little bit more scary than our previous examples. But once again, it is quite simple. So on the here, we have something that we haven't had yet, and we have two terms here on our numerator, x plus 7 minus, so we have one term here, one term here, and one term here. And we can see there's not really much we can do here in terms of exponent laws or what we've been using thus far. So in this case, what we're going to do is we're going to look at it in a few different ways. And when we look at what we are given, we're given a trinomial here, which we know that more often than not, we're going to have to factorize this. And we see here as well, we have a binomial here, and we have a sort of binomial here as well. It is a binomial, right? But we see we can actually factorize this. So we know that we most likely have to find the lowest common denominator here. So how do we find the lowest common denominator? If we're looking at it in a more general terms, so let's just use this format just since that is what we have. So let's say it's A over B plus C over D plus E over F. So in this case, we can see what we're actually going to do is find a common denominator. And there's nothing common here, so we're just going to multiply the denominators. That's what we do when we don't know what else to do. So when we try, we're going to ask ourselves, right? Let's look at the denominators. This first term already has the B. So we left, if you're going to divide BDF by B, so basically BDF by B, we notice that we're going to cancel off the B's and we're left with DF. Now that's important because when we say, okay, B can go into this, yes, it can, and the B's will cancel off and we're left over with DF. So we're going to multiply that by our numerator. So it's going to be DF A, DF times A, and we're going to repeat the process. Here we're going to see, okay, D goes into this, definitely, and we left with BF plus BFC. And then we see, okay, F goes into this, we left over BD plus BD times E, which is BDE. So that's what we're going to apply. Yeah. But before we apply this, we're going to ask ourselves and we're going to check if we can actually factorize anything. Yeah. So x plus 7, nothing we can do about that. We look at our denominator. Can we factorize this? Definitely. We can definitely factorize that. And we're going to have x minus 3, x plus 2. Okay, and we can already see that we're going somewhere because we see we have a common denominator here, something common, x minus 3 and x minus 3. So here we can ask ourselves, can we factorize 3? No. Can we do anything with x? Cannot x minus x. Sorry about that. Can we do anything with x minus 3? Absolutely. And then we're going to do the same with the last term. Can we do anything about 2? Definitely not. Can we do something with this denominator? Yes, we can. 2 into x plus 2. So now when we look at the denominators, everything is starting to take shape because we have x minus 3, x minus 3, x plus 2, x plus 2, and then we have this 2 here. So x minus 3 is common. That's great. X plus 2 is common. That's great. And we have to worry about this 2. So our common denominator will be 2 into x plus 2, x minus 3. So now the important thing is to get our numerator. So we look at this denominator, which we broke down into this. This goes into this perfectly, and we're left with 2. So it's going to be 2 times our numerator, which is x plus 7. We're going to do the same here. We're going to put our minus. We're going to look at this denominator. The denominator, x minus 3, goes into this, and we're left with 2 into x plus 2. So it's going to be negative 2 into x plus 2 times 3. We do the same with the last. So this goes into this, and we're left with x minus 3, because the 2 will cancel off the 2, x plus 2 with the x plus 2, and we're left with x minus 3 plus 2 plus, sorry, x minus 3 times the numerator, which is 2. So on the top here, when we distribute, we're going to get 2x plus 14. Here we're going to get a negative. Okay, let's multiply the negative 2 by the 3 first. Remember, when we're multiplying, we use the commutative property. So we can multiply the negative 2 and the 3. We're going to get negative 6. Just going to put that x plus 2. And we're just going to do the exact same thing here as well. Plus 2 into x minus 3. And we're going to leave our denominator as is, which is the lowest common denominator that we have. Okay, and now we're going to just further simplify our numerator. Negative 6x minus 12 plus 2x minus 6. And yeah, we're going to leave our denominator as is. Now, and we're going to see on the numerator, we're going to look for like terms. So we have 2x with negative 6x and a positive 2x, and we're going to be left with negative 2x there. And then we're going to look at our numbers. We have 14 minus 12 is going to give us 2. 2 minus 6 is minus 4. And our denominator, okay, and then that's equal to, on the top, we can, on the numerator, we see we can take out a common factor of negative 2. And we're going to be left with x plus 2 Then we see we have multiplication and division only, so we can begin to cancel if we see anything that's the same. And we can do that. And we know that negative 2 divided by 2, these 2's will cancel out. We're left with a negative 1 on the top. So that's minus 1 over x minus 3. Okay, so I hope this video helped you guys. And if you want one-on-one lessons, please contact us or drop a comment and we will get back to you. And yeah, hope this helped. And if you guys need anything or have any questions, please don't forget to leave a comment. And if you've watched so far and have not subscribed yet, please do subscribe for more educational content that's going to help you in your future. Thank you.